Let's talk about energy without ideology, just math. In sustainable energy, without the hot air, Cambridge physicist David MacKay did something most climate debate avoid. He asked if an entire country wanted to run on clean energy, what would it actually take? Not emotionally, not politically, numerically. MacKay broke national energy use down into simple metric, kilowatt hours per person per day. In the UK, the average person consumes about 125 kilowatt hours per day across everything: electricity, heating, transport, food production, manufacturing, imported goods. This is critical because most people only think about electricity at home. But electricity is just a fraction of total energy demand. Transport fuels, industrial heat, cement production, these dominate. So MacKay did something brilliant. He put energy supply and energy demand on the same page. He compared how much energy solar panels could generate per square meter, how much wind turbines could realistically deliver per square kilometer, what nuclear could contribute, what biofuels would require in land use. And here's the key insight: clean energy is possible, but it requires scale. For example, to replace fossil fuels entirely with wind power, you would need wind farms covering vast portions of land and offshore areas. Solar works, but covering rooftops alone doesn't meet national demand. Biofuels, they compete with agriculture and land availability. Nuclear, high output, low carbon, but capital intensive and politically debated. The point of the book is not to discourage, it is to eliminate magical thinking. Energy transition is not about installing few panels, it's about redesigning entire systems. 3 strategic lessons emerge. First, electrification is central. Electricity is easier to decarbonize than liquid fuels. That means EVs, heat pumps, and electrified industrial processes, they become structural shifts. Second, efficiency reduces the denominator. If you cut demand through insulation, smarter logistics, and better design, you reduce the infrastructure required. Third, grids and storage are the invisible backbone. Without transmission upgrades and storage solutions, renewables cannot scale reliably. Now let's bring this into the boardroom. If you are in manufacturing, your exposure is industrial heat. If you are in logistics, your exposure is fuel electrification and supply chain redesign. If you are in real estate, building efficiency determines asset value. Energy transition is not a CSR function. It is capital allocation strategy. It is infrastructure risk. It is competitiveness. Companies that understand the physics can anticipate regulation, price volatility, and stranded assets. Companies that ignore the math will be surprised by transition costs. MacKay's message is empowering. The transition is physically possible, but only if we align ambition with arithmetic. Climate isn't defeated by optimism alone. It is solved by engineering, systems design, and disciplined execution. So the next time someone says renewables cannot power the world or solar will solve everything, ask for the numbers. Because physics doesn't negotiate. But when we understand the numbers, sustainability becomes practical, investable, and scalable. I'm Yasmine Barbir, and this is how I see sustainability differently. For more videos in demystifying sustainability and upgrading your knowledge, please follow our YouTube channel and subscribe to our Fusion Minds Academy.